I want to just give a sweet little shout out to our platinum sponsors, Cloud Security Partners, who is represented by Mike McCabe, who was not here with us, but he had spoken with at this event out in April. You can always check that recording then. It was about how to abuse Terraform. It was really cool. And then, of course, my company, Rhythmic Technologies, we're a managed service provider doing cool things on infrastructure in AWS. If you want to learn more about what I do outside of these awesome events we tend to host, please don't hesitate to ask. And so with that, want to give a shout out to Jerry Brooks, who's not here with me, but our lovely ladies and gents are in the back quiet room over there. Skill Center is a very new facility to this area, and it's been really, really supportive to the many meetup groups in this local area. And so with that, it is my great pleasure to have both of our speakers here today with us. You're going to be hearing from Jeremy Snyder at Firetail on the API security, as well as my lovely colleague, Stephen Black, speaking on what's new and happening at the security specialty certification. And without further ado, let me switch over to you.
Okay, great. So the idea is that like API security becomes this critical crossover point between cloud security and application security. So, oh, come on now. You were working so well. So, just a few words about myself. I've been in IT and cybersecurity for the better part of 25 years. I've lived in 4 countries around the world, speak a few languages. Most recently, probably relevant to this, I'm former AWS. By the way, I worked at AWS before IAM and before VPC. So just bear that in mind. Like the only way that you could separate your workload from everybody else on there was with tags. And if you tried to understand like what was workload A and workload B, tags was all you had, buddy. So that is the beginning of my cloud journey. I most recently spent 4 years at a cloud security posture management company that then got acquired in 2020. And I spent a year and a half doing M&A in the cybersecurity space. So I've looked at an awful lot of cybersecurity stuff. Here's my contact info. If you do have any questions afterwards, you want to reach out, feel free to do that. Please do not tweet me. I don't really like that platform. Yes, I don't like it. Whatever you call it, I don't like it. So I mentioned at the beginning that about 62% of developers are using third-party APIs day to day, but actually like one staggering fact that I like to throw into conversations, and this has been like observed and verified by all the major network traffic operators, is 83% of all internet requests are API requests. Not the volume of bandwidth, because like video and frankly pornography is a huge volume of bandwidth, but the number of requests traveling over the wires. And if you think for a second about like the last time you watched the status bar in your browser as you loaded a website and you watched all the third-party calls that it's making, loading Google ads, loading recommended content, loading social sharing buttons, et cetera, et cetera, et cetera. All of these are API calls that are bringing together the construct of the page that you're loading. We have about 50,000 public API services as of last year. It's growing at a rate of at least 2,000 new public API services every year. Minimally, that's been tracked over the last few years. And if you think like there's not a direct correlation between the number of public APIs and the number of endpoints, but we are on track towards having 1 trillion endpoints in about a 7-year period. So let's do a little quiz. How many of you have used a mobile food ordering service? Uber Eats, DoorDash, what have you? Great. So that's like pretty much everybody. If you had to guess, this is kind of the logical layout of one of these transactions, right? So you download the menus, you select your items, you place your order, blah, 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 right? That gets sent to the platform, gets sent to the restaurant, gets sent to a delivery service, gets sent to a payment provider, all of that. How many API calls in this transaction? Let's get a 0 to 10, show of hands. 10 to 20. 20 to 30. Okay. 30 to 40. Above 40. Yeah. So I was talking to an engineer from one of these companies. We got to 25 and we quit. And he's like, there's at least a dozen more. So I don't actually know the exact answer, but it's somewhere towards the high end of that 30 to 40, or it's over 40. And this is just one single transaction. But let's think for a second about what data is in there. There's actually a lot of PII in there. I have my name, I have my home address, or wherever I happen to be at that moment. I have my mobile phone. And by the way, Also, my payment credentials were sent over an API, right? So we've got both sensitive data, and we've actually got like a mission critical piece of this transaction chain being executed over APIs. So I like, you hear various analogies. APIs are the connective tissue of the internet. APIs are the plumbing of the internet. The truth of the matter is they're connecting like pretty much everything across the web right now. And if you're building a modern application, you 9 times out of 10, you're not going to like rebuild a piece of functionality that you need that's available from a third party, whether that is an internal service component that you can call or whether that is an external service provider. Just for fun, if you're wondering like how big is the problem, we've been actually tracking all of the publicly disclosed API data breaches that we can find. If you're curious, look on the footer of our website, you'll see a little link to the API data breach tracker. So over the last, this is outdated. This was from about 3 months ago. So I do need to update this when I give this talk again. This should actually be over 1 billion at this point. In the last couple of months, there have been some very, very, very high profile API-based data breaches and security disclosures that had massive impact. There was one recently, a back-end white label app that powers systems like the New York City Metro, over 1 billion user records at risk of exposure through API weak authentication practices. So like that on its own is over 1 billion. How many people have frequent flyer accounts? Yeah, awesome. How many of you read the points.com thing? 1, 2, awesome. 3, yes, you don't count. Sorry, like you had to, but they chose to. So every single frequent flyer user, every single hotel points user, and this is like all the major airlines, all of the major hotel chains, United, Delta, Southwest doesn't have one, American, Marriott, Hyatt, Hilton, etc. All of them use the same system, points.com, for tracking their loyalty programs. That system had about 5 API vulnerabilities around it that could have led to both the extraction of every single user record and like every detail in that record, as well as the ability to give yourself unlimited miles or points on those platforms. I know it was actually really fun. If you ever want to read the disclosure, samcurry.net, he's the researcher whose team found this stuff. It was really funny. He says, we got to this point and then we faced an ethical dilemma. Do we give ourselves unlimited miles or do we disclose this? But great. So a couple of things that are really interesting to note about this. One is that like the top 2 causes are actually authentication and authorization. So when you build your API, do not conflate authentication and authorization. They are not the same thing. Authentication refers to establishing your identity. Authorization is what can you do? What are you allowed to do? And there are actually 2 dimensions on it. One is what data are you allowed to access? 2 is what functions are you allowed to access with that data? As an example, social media app, I may be able to view and edit my own profile. I may be able to view but not edit Banjo's profile, right? So there's both data access and data functionality access. That turns out to be the root cause between almost all of the authorization problems. There are 2 particular categories called BOLA and BFLA, broken object level authorization, broken function level authorization, that are common problems around APIs. If you want this, by the way, like there's the data breach tracker. You can also download the full report off our website. A couple examples. I'm just going to pick one because I don't think we have time to go through all 3 of them. There have been some very, very large scale ones. This is actually very typical. When there is an API data breach or a vulnerability, it tends to expose the entire data set. Why? Because it is a logical flaw that applies to every single data record in the set. So here you see, I see your facial expression kind of shows your reaction, but like 100 million records from the Starbucks mobile app. By the way, that was thankfully a responsible disclosure. That was not actually like leaked out into the public or sold on the darknet. But it was the discovery of an undocumented API that had no data query restrictions on the API. So you have security through obscurity, not a good practice. And then you have no limitations on the API, neither in terms of rate limiting or pagination of the result set coming back. People familiar with those terms? Yes, okay, great. Or in terms of what you're allowed to query. So GraphQL, awesome new technology, allows for select star. Maybe not a good look for a production API endpoint, right? So you might want to have some limitations around what's going on there. Okay, sweet. All right. So I'm sorry you had to bear with the notes view. It wasn't too bad though. hopefully. But yeah, so that's an example of what goes wrong in API data breaches. So a couple of other things that we might notice from them, and apologize, we don't have time to go through all of them. In almost every case, more than one thing goes wrong. So there's almost never one single thing that on its own screws up an API security situation. Think about that example. It was an undocumented API plus no restriction on the query. Either one on its own would have greatly limited the scope of the breach. And so when we've looked at this, we've seen it's not industry specific or geography specific. We've tracked in our tracker events from pretty much all around the world. I think pretty much every continent has been represented in the data set in one way or the other, either through third-party apps or through homegrown apps. Couple industries do stand out. Manufacturing, why? Because it has a big supply chain. And supply chains nowadays are both physical and digital. And so when you have this kind of digital aspect to your supply chain, how are you interchanging data between partners? APIs, right? Secondarily, technology, right? Because who builds APIs? Tech companies, software companies, right? And third, hospitality. This has actually been like maybe the largest single category. So I should update this one as well. This one is outsized representation in the data set. Obviously, the points.com thing that I mentioned earlier was big, but even before that, there have been a number of issues around various airlines, various hotels, rental cars, travel industry in general has been. Okay, so that's the backdrop of API security. So you may be asking like, hey, your title was API security is where cloud security connects, like you haven't said anything about cloud security. So let's talk about cloud security for a second. So I spent about 6-7 years working purely on cloud security. I was working in this space before Gartner came out with the acronym CSPM. How many people know that acronym? About half. CSPM, Cloud Security Posture Management, it's a very common approach to cloud security today. It really means fetching the configuration of all of your assets. It's like checking, is the config of your S3 bucket open to public or not? Does your bucket have a policy on it? Does it have IP address restrictions, et cetera, et cetera? So 2016-17, when I started working on this space, what did we see? We saw a bunch of breaches and we saw a bunch of issues. So Booz Allen Hamilton, anybody work for Booz? Anybody worked for Booz when that happened? Yeah, all right. I figured there was a high probability with the people in this room that there would be somebody who was connected to that one. Dow Jones, probably no Dow Jones people. And Elasticsearch server, I'm trying to remember who that was. StoreHub, there you go. But what's the common thread in all of these incidents? Anybody know? Configuration. There was no attack. There was no hack. There was no break-in. There was no brute forcing. There was no social engineering. There was no phishing. There was no anything. These were literally just data exposures. Companies left data public accidentally. So that was the case for about 3 years. And what ended up happening over time is that companies started to get better, both the security vendors and organizations themselves. And by the way, the cloud providers as well, I have to say. They went from kind of like open default configurations to secure default configurations. And you really have to go out of your way to leave some of this stuff exposed to the public nowadays in your configuration. So kudos to those who have worked on that kind of stuff. But what I saw was that you had to actually think about kind of the model of operations and how you were building your technology architecture on the cloud from the level of the cloud infrastructure all the way up the application stack. And the model that I use to kind of inform my own thinking around it is this kind of very basic 4-quadrant model. So you've got a time axis here on the x-axis, right? How am I doing on time? Great. So on this time axis, you can basically think about, pre-production and production. And on the y-axis, think about this as your tech stack. Infrastructure layer, operating system, and above. We're going to come back to that in a second. I actually built it off of the 7-layer OSI model because I found that to be like kind of the commonly referred to framework that everybody would think about. And so when you kind of map that out, you've got basically a tech stack that kind of starts at the bottom. This is like network, storage, compute, right? So you kind of start from the infrastructure layer and then you work your way up into understanding where the 7 layers map to those quadrants. And you kind of end up with this model overlaid onto the quadrants. And really what that ends up with is like, you've got your production infrastructure, your pre-production infrastructure, your pre-production application, and your production runtime. Does that all make sense? Great.
Should that say post-production?
No, that's production.
They're both pre-production. Oh, I'm sorry.
Yeah. No worries. So, great. They fail to use secure features. Technically, like you can use the APIs to make those configurations. And technically, for a lot of them, you're using APIs to access the data. I would not consider those to be API security breaches. That's a different category of thing. We'll come to that more a little bit later. Awesome. So these are kind of the framing that we saw. And so where have the breaches happened historically? Like pretty much every single breach was in production infrastructure environments. There may have been 1 or 2 that were pre-production environments, but almost everything happened at that infrastructure layer from the misconfiguration of storage, network, or compute components. And so this was exactly the problem set that tools like CSPMs, Cloud Security Posture Management, set out to solve. Now, what did we see happen? What we saw happen was actually that the attackers got smarter. The way I like to think about it is like hackers started using AWS too. And by the way, like hackers been using AWS for like ephemeral IPs for a long, long time. We all know this. It is known. But what started to happen was like, anybody work at Capital One or worked at Capital One or is willing to say that they worked at Capital One during this time frame? Yeah. This was, I think, an eye-opening moment for many, many people in the cloud security world. Why? If you analyze the attack path that was taken here, you started from an application vulnerability on a single EC2 instance that led to access to the metadata service, that led to access to the IAM service, that led to basically the ability to kind of probe and enumerate the environment by querying CloudTrail, that led to the discovery of an S3 bucket, that led to exfiltration of the data. So now we well and truly move beyond the simple, oops, I left it open to the public, to holy crap, I need to think up and down my entire AWS tech stack for how I'm configuring things and what is the implication of the connection of this resource to that resource, and the implication of a misconfiguration here and what it can lead to in other parts of the environment. So we get to much more interesting environments and much more interesting set of challenges. I'm going to skip this. So at the same time, what we saw was the vendors start to add tooling that started to move up the tech stack. How many people here use Palo Alto Prisma Cloud in your day-to-day? A couple of you. Wiz? Orca? Lacework? Cool. What you would have seen from those companies, if you looked at them in 2016, 2017, maybe even 18, was a focus that kind of ended right about here, right? They covered the infrastructure layer. Then starting in 2018, 2019, they started to move up and up. They added coverage for containerized environments, Kubernetes security posture management, access to IAM, and understanding the implications of the identity graph, and so on. So we saw that the providers started getting better at providing coverage up to a certain level. The missing piece that we identified back then was, oh crap, nobody's covering the APIs. And by the way, that's going to be a real problem. That was actually the genesis for Firetail, in case you were curious about it. Another note from the security of emerging technology. So I saw this in my cloud days. We're seeing it again on the API side. I started this earlier today. Type in developers don't in the letter C in Google, and the first suggestion that comes up is developers don't care about security. It is the #1 autofill result from Google. And so what ends up happening? Developers get empowered to go do things that they need to do. Why? Because the business demands it. It's like, hey, Banjo, you need to go deliver this new rideshare app. Go make it happen. And by the way, ship by Friday. You know, like that's the kind of pressure that happens in organizations. And then, you know, security, quote unquote, gets out of the way, right? And lets people do what they need to do. Well, what does that lead to? This leads to a situation where the technology has gotten ahead of the organization's ability to manage the risk around it. So what we tend to see is then a need to understand it. And that understanding usually starts in the flavor of discovery and inventory, because why? Security doesn't even know what's going on in the environment. So I don't know how many of you have ever done, like, let's say, security consulting engagements around AWS or around any of the cloud platforms or your customers, but pretty much everyone you walk into, the first thing you'll say is you say, well, tell me what about your environment. They'll be like, I don't know. I know we have some of this and I know we have some of that, but we probably have other stuff too that I just don't know about. And like the number one rule in security is if you don't know that it's there, if you don't have visibility, you cannot protect it. Plain and simple, right? So you tend to get this kind of discovery and inventory as the first process. And then the second process tends to be like, oh crap, there's way more stuff than I realized. I don't even understand what's important. What are the implications here? Is it good? Is it bad? We got a bunch of stuff. How good or bad is it? So you tend to use a policy lens. You might use something like a CIS benchmark. You might use something like a NIST cybersecurity framework as a way to assess. And then usually from there, you look at mitigation. Where do we apply attack prevention, defensive techniques? Where do we just turn on logging and monitoring? What's the right path? One challenge around this that we see also in API security, I stole this from Qualys just because I found it to be indicative. I don't endorse their product or not endorse their product. But one of the interesting things is like, you walk into these environments and you end up with numbers like, oh, I have 8 million exposed workloads and I have 7,500 running containers. This is not atypical of what you'll find running inside larger organizations when you walk in, when security teams walk in to try to get a handle on the situation. So, great. All of this is not said to kind of scare you and tell you like, oh crap, things are really, really bad in the world of API security. There are challenges to be sure, but we do know that APIs account currently for 90% of the attack surface exposed. Again, why? Because we're using APIs in ways to interact between organizations. Data is crossing boundaries between my control and your control. With that said, the API is the thing that I'm exposing at the edge of my AWS environment. So that is where my kind of academic study of the last kind of 10-ish years that I've spent working on the security space has led me to figure out that APIs are going to become one of the biggest problems over the next couple of years. If you're interested in more information, feel free to scan this. This actually is a QR code. This will work. If you want to download the report, you are more than welcome to it. And I don't know, Christina, how we doing on time to take Q&A?
You have
15 minutes, a whole 15 minutes. I got through that way quicker than I thought. Cool.
Yeah, great presentation, Jeremy.
Yeah, thanks.
I had a question about, first, how do you identify how the breach was? Because I don't understand a lot of organizations don't know how it happened. Right?
Yeah.
So you have a chart there that identifies everything, but I thought most of the breaches were they did not know.
Great question. So let me try to go back to that chart to talk through our methodology, because the disclaimers on this, which by the way are on our little tracker, is that we work off of the publicly disclosed data. So to that end, we can only go off of what's available to us. There's kind of a common conception that like what has been publicly disclosed is a percentage of what's actually happened. So you don't know like if there have been more breaches, et cetera. Now, with that said, what we've tried to do is we read the reports. If it's a responsible disclosure, usually that's very detailed and that's great. If it's a hack, you usually have to wait and then get about 3 or 4 sources on it. And typically each source will have one piece of the puzzle. So we have a security researcher on our team who is responsible for reading these things and then trying to work backwards. He also goes out and tries to use the APIs to try to understand where he himself can locate the vulnerabilities. He's great, by the way. But he is the guy who does most of this classification for us. It is based on best effort, best knowledge that is publicly disclosed. There's definitely like a caveat that like, this is what we know best. Sorry, this is as best as far as we know. There may be some that we've misclassified. We do leave some blank, and we also do a primary and secondary classification around it, where we think like this was the first thing that went wrong that allowed access to the environment. This is the second thing, which is usually about what allowed the data to get exfiltrated. But it is best effort, and like, yes, you're right. Like this may not be 100% gospel truth, so please don't take it as such. Yeah. absolutely. So average cost is hard because that's a contentious data point. Like the IBM report always says something in the neighborhood of like $130 to $160 per record. What I can tell you is that the average number of records per breach is about 13 million. And, the weird thing though is that there's like big outliers. There's like ones that are over 1 billion, and then there's ones that are like a couple thousand because it's a small data set. It does tend to be, like I said, the entire data set. If you took that like IBM number times our average from the data set, you're into like the billion per incident cost, which honestly doesn't seem realistic. So I would definitely like take that with a huge grain of salt. Yeah, like a 96-hour or 4-day disclosure window behind any breach, something like that. Yeah. So I expect the number of, first, I expect the number of breaches to go up just because of the adoption patterns and like the attackers getting more sophisticated at using this stuff. But also because of things like what you said, the disclosures are going to be more regulated and more required. So yeah, for sure. Yeah. Question.
Congratulations on making a great job decision.
Thank you. Yeah.
And that's what we call a growth market, right?
We hope so. Yeah. Should be. Should be. I mean, it's a problem. Yeah.
So I want to ask you, what's the motivation, the consequence, and the benefit behind the breach?
Yeah.
The assailant.
Yeah. Yeah. So it's all about I shouldn't say it's all. Our understanding is that every one of these breaches that we find is financially motivated. And you can be pretty darn sure that your data has been in at least one of these breaches. The motivations for the most part seem to be, how much information can we get about you that allows us to either manipulate your financial situation, steal money from you, or steal your identity, and then establish lines of credit, extract financial value, extort your organization, whatever they may be. But definitely like financial motivation is the leading cause or the leading motivator as far as we see. Yeah.
And then following up on that.
Yeah.
What you estimate is the domestic versus international?
Great question. I haven't actually analyzed that in our own data set. We didn't do a good job of breaking that down by like US versus non-US. I don't know. I don't have an answer to give you, but like yeah.
So
yeah.
Don't have anything on the financial industry. Experian had a huge data breach.
Experian had a huge data breach. That was an application vulnerability. That was actually not an API. Yeah. Yeah.
I guess when it comes to the developers not caring about security, I'm just using an API. I want to eventually get something done.
Yeah.
How would you, I guess, educate developer teams to kind of just think about APIs and other attack vectors without needing it?
Yeah.
Consider this might be a hack someday.
Yeah. It's a great question. Look, we're trying. So what we do at Firetail, and I mean, I don't want to get into like the Firetail sales pitch because that's not why we're here. But one of the things that we've done is we've tried to make it easy for developers to ship secure APIs. So we have a set of open source code libraries that any developer can grab. What it does is it takes an API definition, typically written as a spec file, and it actually turns it into a set of active controls. So API requests come in, they get evaluated, they either get dropped or they get passed forward if they meet the security requirements. But to that end, it is an educational process. We have a little glossary that we're putting together around good API spec file practices and like what is and is not a secure development model around various things. We have about 50 different items. If you go on firetail.io/finding, it's very crude, rudimentary documentation right now, but it does have code examples of like, this is a mistake relative to data record numbering. Like you shouldn't use integers, you shouldn't use sequential. Here's what you do instead. We're working on that. It's definitely part of our mission is to try to make it better. Yeah, we do. Yeah, Open API spec is the main kind of document definition that we support. Yeah.
Yeah, related to a question over there. I think there's also a lot of people who's doing it for clout, like that guy military guy that put all the top secret files on the Discord server.
Yeah.
And related to that, I was going to ask, sounds really cheesy, but fraud GPT is supposedly a thing. And I was wondering what your take on that, and whether there are people out there using, certain generative AI to create, code to basically find vulnerabilities.
Yeah. Yes and yes and yes. So the to kind of like clarify or expand on that. Look, I don't know if fraud GPT, how real or fake that is, but I can tell you from having worked at a company that had one of the leading pen testing tools on the market, the amount of criminal usage of that tool was at least equal to the amount of legitimate usage of that tool. Every tool that you build that has some capabilities to find security vulnerabilities will get abused or used by, the other side, so to speak, the bad guys. So I know very much that there are tools actively being used. There's a whole category of tools on GitHub that you can find that will do things like, oh, I've discovered a GraphQL API. Here's a set of tools that I can use that will give me the entire data schema behind that GraphQL endpoint if the endpoint is not well restricted on the query. So if fraud GPT is real, absolutely people are using it. Yes, they are absolutely using API security testing tools as well for bad purposes. Yeah, like 100%. Yeah. So API gateways have a great set of security features, but they don't cover all the use cases. And in fact, I would argue from our analysis, they don't cover actually the top ones. So API gateways are really great at limiting the scale of an API breach. Why? Because they can do rate limiting for you. They can paginate your responses. They can limit the amount of data going in chunks, and they make the attacker request again and again and again. And then you can hit them with the rate limit and kind of like stop them from getting everything. So that's a great set of features that they do from a security perspective. They cannot tell you that your API is doing proper authorization checks, and they cannot do those authorization checks for you. So they're like helpful, but not sufficient. I do know some people do authentication checks on API gateways, yeah. But again, not authorization. Question over there?
Two questions. I'm curious to know how did you begin finding your initial customers?
Yeah. Oh, yeah, for sure.
My second question is, how and when did you determine that what you are presenting is part of market?
Answering the second question first, still on that journey. We're still evolving the product a lot. Even in the last 3 months, I can tell you that we've added 4 to 5 new, like brand new sections of the product around API incident response, forensics, et cetera, in response to customer demand. So like there's still a lot going on that side where I would not tell you, like I would not stand here in front of the audience to say like, oh yeah, we got product market fit. This is the product and this is what it's going to be. Like we're not there yet. To answer the first question though, how did we find our initial customers? We actually reached out to a bunch of companies we know. My co-founder and I, we just reached out to 30, 40 companies that we knew that were kind of leading edge, innovative. We suspected they had a bunch of APIs. We asked for 30 minutes to kind of present our initial thesis around where we saw the problem. And some of them said yes, a small percentage. Yeah. Just same conversation again and again and again, and get more feedback and learn and keep going. Yeah.
Question from Ripple. Is there a management maturity model when scoring an API?
No. This is actually one of the challenges around API security today. There is exactly one model of assessing API security, and even that model is just a risk matrix. It's called the OWASP API Top 10. It is not a set of technical controls. It is also only loosely ranked from 1 to 10 in terms of descending importance, so to speak, but there's no scoring around it. There's no like evolving maturity over time, et cetera. Frankly, it's like an okay starting point, but that's about as good as I would call it. Yeah.
Is there a concerted effort to hack certain repositories that actually have the secrets, for example, AWS Secrets Manager or LastPass, for example, for the LastPass for API?
I think the RSA database got hacked.
Sorry,
The RSA fork.
Oh, the RSA, yeah. Oh, I didn't know. I missed that one. Yeah.
You know how RSA works.
Yeah.
You can screen the initial seed,
Then you get all the codes that follow from it. I do know that there are like a lot of efforts to hack these kind of central points. Actually, like how many of you have been following the Move IT thing? Yeah. We just did an analysis of, and this one we're very clear to say this is a potential attack path. Nobody can actually confirm the exact attack path. But out of the 5 steps to breach Move It, 2 of them involved APIs. APIs were used as the initial delivery point for the malicious payload. It's actually really clever if this is the way that it played out. It's an encoded payload that gets serialized and then delivered to this API endpoint. The API endpoint just processes it and sends it to the app server. On the app server, it gets deserialized and decoded and then executed. And that is actually the malicious payload. So the API was kind of the entry point on that caused the bad server behavior that sent data out. But exactly like in line with the line of thinking that you're asking about, there are concerted efforts to hack things that have massive ecosystem impact. This one, like Move It, is well over 1,000 organizations impacted. We're in the hundreds of millions of records at this point. It's pretty massive. So yeah, there's definitely a lot of focus on like, oh, what are, let's say, common APIs that connect many organizations that we may be able to gain a foothold. Yeah, that's a huge target for sure. Yeah. Maybe time for like 1 or 2 more. There's one in the back. Yeah. Uh-oh. I just got done saying 1 or 2. No, just kidding. Go ahead. Yeah. Yeah, sure.
Isn't AWS use all pretty much use all API call?
Yeah, but I guess the one distinction that I do want to draw, like I'm not here to talk about the security or insecurity of AWS APIs. Those are for instrumenting various pieces of the infrastructure and the platform, et cetera. When I say API security, I should really say like APIs that you guys are writing for your own software, like not the provider APIs, just to be clear. Yeah.
And I guess the couple part of the question is related to the cybersecurity. Most companies they just buy breach insurance, right?
Yeah.
And if they lose some data, they'll just give away Expedia credit.
Yeah. Look, here in the US, that is a very common practice, but I will ask you this. How many of you have gotten cyber insurance policies in the last year? Yeah. Have you seen the rates? Yeah. Rates have like almost tripled in the last couple of years. If that's how you want to treat it, like great. Just know that your insurance tax is going up and up and up. And, there are cases in litigation where the insurance providers are now like basically saying, okay, part of that insurance policy, though, is that you have to follow best practices. You didn't. You, the customer, are responsible for your breach. I think there's going to be a lot of cases like this in the next couple of years that test like, where is the line between like, okay, you got hacked, you got breached by like no fault of your own, or you should have known better, or you should have done better. I don't personally, I think you should do everything you can do to protect the organization, but obviously I work in cybersecurity. So like, I'm going to say that and going to think that. So anyway, you said you had more questions. Okay.
How do you motivate companies
to
improve that API?
Yeah.
Right?
And spend money.
Well, do you think that like web application firewall able to improve and capture some of this stuff?
Some, yes, not all. The real challenge around WAFs in general, well, a couple challenges. One is like I've talked to a lot of customers who bought a WAF, either never turned it on or never turned it on everywhere because they're terrified of blocking the good traffic that their WAF wants to block, the 1 out of 10 or the 1 out of 100 that should have been allowed through, that might have been a legit e-commerce purchase or something like that, right? So there's a lot of like hesitancy around that. But the second part is like, actually, again, when you come back to what went wrong, 9 times out of 10, the breaches that have happened around APIs look like normal API calls. And so, me requesting your data because I just changed one ID in a request parameter string like that's to a WAF that's going to look normal, right? And so the WAF isn't going to do anything around these kind of logical exploits. That's the challenge. Like WAFs are still very much like IP range, port, protocol, maybe country, maybe geo, whatever. But it's like port, protocol, endpoint blocking. It's not like, oh, don't let him request unauthorized data. And that's the type of challenge that we have on the API side. So I think WAFs are helpful, but they can't prevent logical problems.
I guess I will follow up with that because you answered that. I mean, I think it's a lot of, or some big organization would, put all the log into a SIM. And
Yeah.
They can,
Yeah.
Do some sort of behavior
Yeah.
analysis,
Yep. Yeah.
Things like that.
Yeah. Look, that's also very helpful. And to the extent that you have the resources to do that, you should do that too. And in fact, like we actually output a lot of the stuff that we interpret into SIMs for our customers as well. We do some pre-processing around understanding like what went bad from an API perspective, and then we send that enriched data to a SIM. So yeah, it's not either or. It's like, what resources do you have available and what works for your organization? Yeah.
Can I ask one last question?
I don't know. She'll say yes or no. Okay. That's okay. Okay. Do you need it for the next presenter? That's totally fine. Yeah, great.
Frequency
Of
you talked about, increasing.
Yep.
Situation. So what have you seen? Have you tracked frequency?
We have. Yeah. So with our tracker, we've tracked the date of disclosure of every breach that we know. We don't know exactly the date that it happened. We only know the disclosure dates, but working off of that, what we've seen is that the last 2 years, it's kind of doubled and doubled again. So 2021 doubled over 2020, the number of API security breaches, and then 2022 doubled over 2021 again. So the frequency, now, is it the frequency of the breaches or the frequency of the disclosures? Don't know. We can only go off of what public data is, but it is indicative, I think, that the trend line is very much like ramping up in terms of the number of breaches relative to APIs.
So reported breaches versus actual breaches are usually correspond.
Should correspond. It should normally be a percentage of all the breaches that happen will get disclosed. And like we talked about, I think that percentage will go up because of the requirements. Yeah. Yeah, there's definitely more than what gets disclosed. Yeah, for sure. Yeah, cool. Awesome. Thank you all for the questions. Like I said, Jeremy at firetail.io. If you have any follow-up questions or anything like that, you're welcome. Thank you. All right.
All right, folks, thank you so much. And another round of applause for Jeremy. If you would mind anything Firetail, please do check them out. Like I said, Jeremy used to run this group himself. He's been a great supporter of this community and has supported me getting on board with all of this, especially last year in our first annual AWS Community Day. Without further ado, it's my pleasure to introduce to you my colleague, Stephen Black, who I love forcing him to talk. He's so good at it. I will share with you on the new stuff happening with security specialty certification. Take it away, Stephen. Thank you.
All right. Thank you, Christina. So I'm Stephen, and as Christina might have mentioned, I work with Rhythmic Technologies, and I'm going to talk about the new update to the AWS Certified Security Specialty Exam. They came out with a second version, I think it was maybe 2 months ago. Why should you listen to me? Well, I passed it yesterday. I recertified yesterday. I passed it in 2020, and then you need to recertify every 3 years. I also hold a bunch of other AWS certifications. Well, I've got almost 30 years experience with taking standardized tests, so I'm really good at multiple choice. Let's look at how it has changed domain-wise. So this SCS CO1, that's the old exam. SCS CO2, the new exam. For the most part, it's the same, but you'll notice the new one has 6 domains instead of 5. They've added a management and security governance domain. What does that mean? It's basically a area of focus where they're trying to make sure you know how to secure your entire organization, which is maybe more than one AWS account, maybe in AWS organizations, maybe you're using AWS Control Tower. But it's probably a lot of different developers working, maybe not in synchrony. Whereas before, it was very much just oriented towards, do you know how to secure the individual AWS services, which is still going to be the bulk of the exam. It is still the bulk of the exam. But yes, now they have added AWS organizations, and they changed the name of the first two domains, but let's look at the content because it has not changed a whole bunch. Yeah, well, they have prepended threat detection and to this domain, but it's still very much like trying to figure out, do you know how to prepare for, detect, and respond to a security incident? The big one here is going to be AWS Guard Duty. It looks for sus activity, and they like to, in their little about Guard Duty, say it uses ML. But really, it just processes information from all the other AWS sources like CloudTrail and CloudWatch and whatnot. AWS config, that's going to show up here and again in the management section. And it can record the configuration of all of your different AWS services, as well as alert you if someone changes a configuration, or it can audit your configurations to make sure they are in compliance with whatever standard you choose. They give you a few to choose from. So I highlighted Security Hub here because it's pretty new to the AWS game. I think it's like 2017 they released it, but it's receiving more focus. And just know that it will get alerts from other AWS services that something's out of configuration, and then you can do something about it by using EventBridge. Also, while I was studying for this exam, I found out Amazon Detective is a real service, so I threw it on here. And it integrates with Security Hub too, just for collecting information and investigating individual supposed security incidents. So the next domain, security logging and monitoring, they want to make sure you know how to set up monitoring, logging, and alerting, and also that you can troubleshoot those situations. A lot of the questions aren't going to be given to you as maybe I'm giving you the information, like can X, Y, or Z service do X, Y, or Z. It's going to be, Sally is a SecOps developer, and she's trying to make sure her organization can provide secure templates to the whole organization. I took the exam yesterday, and I didn't think you were going to really need to know VPC flow logs other than that we're networking logs. But one of the questions was actually read these VPC flow logs and tell me why this traffic got denied. Wow, it's very detailed. But for the most part, it's very high level stuff. No CloudTrail, it's just recording all the API activity between you and AWS. Remember, AWS is really just a set of APIs that sit out on the internet, and you can throw information their way. And if you throw the right information their way, they will make things happen behind the scenes and stand up EC2 instances or S3 buckets or whatnot. CloudWatch, that's for application logs. You just need to know that, and know that if you're trying to forward application logs from an EC2 to CloudWatch, you need to install a forwarder on that EC2. Then the networking logs, the VPC flow logs, and the Route 53 resolver logs that may show up on there. And then the alerting part of monitoring, that's going to be probably a combination of SNS and Lambda, or like I mentioned before, Security Hub and EventBridge. So 3, infrastructure security. I think when people think of cybersecurity, this is what they think of for the most part, but it's securing your compute. And this is the biggest part of the exam. You're going to need to know the security layers, like Jeremy was talking about WAF, and how do you protect that DMZ, that very topmost user-facing layer. Know that WAF is there, and know that it can integrate with either CloudFront, the load balancers, or API gateway. You're going to need to know AWS networking really well. So know that VPCs are your own network in the cloud. Know security groups are your stateful firewall that protect all your ENIs. Know that NACLs protect your subnets and are stateless. VPC endpoints are going to show up a few times, and VPC private link. So if you don't know about VPC endpoints, VPC private link, VCP endpoints allow you to contact AWS services without traversing the public internet, which is great if you need to meet compliance requirements that require you to not traverse the public internet. Now, let's say you're working with a technology like Snowflake provides AWS private link to its enterprise customers. AWS private link allows companies to create their own VPC endpoints and then provide them. Then we were talking about not traversing the public internet. VPN, AWS's VPN service, and Direct Connect. Know that Direct Connect basically is a cable between your data center and the AWS cloud, and that VPN is encrypted communications between AWS and your computer. You may see ECR and Image Builder on here for container or image hardening. I didn't when I took it this most recent time, but the previous time it definitely was on there. And then scanning with Inspector. So once you've set up an EC2 instance, you want to make sure there isn't malware or anything on there. Inspector will scan it. So for identity and access management, it's how do you authenticate and how do you authorize users to AWS? So know IAM inside and out, the service roles, the policies, manage policies, know the different components of the policies. You're going to need to know how to authenticate those users. So it's probably going to be SSO, and it's probably going to be Identity Center. They just changed the name to Identity Center from SSO. And then you may see Cognito. That's another service that you can use to store user data in AWS. But if you see Cognito, it's probably going to be authenticating users to an application. But not a lot here has changed. Data protection. So this is protecting the storage, the S3 buckets, the EBS volumes. And the big guy here is KMS. Know how it integrates with all of the different AWS data services. So like how it integrates with EBS, S3, AWS backup. That's going to be on there almost certainly. No S3 lifecycle policies and object locks, how you can use those to make sure data stays around when you need it, but doesn't cost you a whole bunch. And then resource policies are going to be very important. Particularly, I mentioned KMS and AWS backup. I guarantee you're going to see a question about, hey, we've got this multi-account setup, and account A has got these applications in it. Account B stores the backups. How do we get the backups from account A into account B and make sure they're encrypted properly? Well, you need to use a KMS resource policy to allow account A to use the KMS key in account B to encrypt the backup for putting it in AWS backup and copying it. Yes. And also resource policies. I've seen questions where they will ask you to create a resource policy to make sure people, when they communicate with S3, that they are doing it over TLS and not unencrypted communications, or they're using MFA. That's going to be on there. So then this is the new domain, and this is actually the one I did the worst in, but it's management and security governance. It's how do you make sure the entire organization is secure? They have a product called AWS Organizations, and that's going to play a big role here. It integrates with a lot of these other services like Security Hub, GuardDuty, and Config. You're going to need to know service control policies, SCPs. I think that stands for something else. Secure. I don't know. But you're going to need to know how to prevent your member accounts from shooting themselves in the foot. Like, let's say you have a AWS organization and you want to make sure all your member accounts can do all of the things except turn off CloudTrail and GuardDuty. Well, you're going to need to know the SCP to be able to service control policy. Thank you. to do that. And then understand delegated administration. They are adding more and more services. It feels like every day where you can delegate and administer in AWS organizations, to where you can make another account the account that handles CloudTrail or backups or identity. CloudFormation, when I found out this was in that section, I was confused because I was like, that's an IAC tool. But you can apply CloudFormation across an entire AWS organization in all the member accounts to create whatever resource you want. You can also provide CloudFormation templates to developers so that they have a secure template when they go to create their resources. At Rhythmic Tech, we mostly use Terraform for ISC, but CloudFormation works too. And CloudFormation actually integrates really well with the service catalog. Yes. And then you can provide templates in service catalog and then allow developers to go and click their way to glory when they want to spin up a new environment or whatever it is that they're developing. And then understand how Security Hub is basically the security event aggregator for your entire organization. How GuardDuty integrates with Security Hub to provide a lot of the alerts, and AWS config, its rules, and you really just need to know that it provides a configuration baseline. I didn't see a whole lot of very detailed questions on AWS config, but it shows up a lot. Yeah, so in summary, AWS is getting more serious about its multi-account setups. Judging by the exam, by the exam guide, they're going all in on Security Hub because it was on there 9 times, which was second only to IAM, which was on there 16 times, and could be its own exam. And if this stuff doesn't excite you, I get off to it. So you can contact Christina about how to get me to build your stuff.